Hello, hello. Is my voice is audible? Is anyone there? Hello, hello. Okay, thanks. Thank you very much. Good morning, everyone.
Hello, good morning. So please join. Shubhodip, good morning. Shubhodip, are you hear me? Okay, good morning Shubhodip. Please tell other to join. I see only three of you watching. Please tell other to join. Shubhodip, are you hear me? Please tell other to join. Okay. So first I start with a problem. Consider the independent random variable y1, y2, y3 having common variance sigma square with expectation of y1 theta 1 plus theta 2, expectation y2 again it is theta 1 plus theta 2, and expectation y3 equal to theta 1 plus theta 3. Okay, so first part of this problem is find condition of estimability of linear function So you know the process of solving this problem. So you know, first you find matrix A, which is okay, then find augmented matrix of A lambda curl, and then I think A prime lambda curl. Okay, and then rank of A prime. So if these two things are then find from this equation conditions of lambda curve. So please do it yourself. This is your homework. Okay, or you can find it another way. Suppose L curl prime y curl, that is L1 y1 plus L2 y2, L3 y3 is an unbiased estimator of lambda 1 theta 1 plus lambda 2 theta 2 plus lambda 3 theta 3. Then expectation of L curl prime y curl, that is L1 theta 1 plus theta 2, L2 theta 1 plus theta 2, L3 theta 1 plus theta 3. So this is equal to lambda 1 theta 1 plus lambda 2 theta 2 plus lambda 3 theta 3, or lambda 1 lambda 2 lambda 3, this is equal to theta 1 lambda 1 plus lambda 2, this is into theta 2 plus lambda sorry, this is L, not lambda, L3 theta 3, and this equal to lambda 1 theta 1 plus lambda 2 theta 2 lambda 3 theta 3. So comparing both sides, we get L1 plus L2 plus L3, this is equal to lambda 1, L1 plus L2, this is equal to lambda 2, lambda 3 equal to L3. So from this 3 equation, we see that lambda 1 plus lambda 2 plus lambda 3, sorry, we see that lambda 1 equal to lambda 2 plus lambda 3. So lambda 1 theta 1 plus lambda 2 theta 2 plus lambda 3 theta 3 is estimable when lambda 1 equal to lambda 2 plus lambda 3. So you can find this condition this way, or you can use this result. Okay, so please, this is your homework, and check that after this condition satisfied when this thing is happening. Okay. So next problem, next part of this problem, S is due to blue blues to theta 1 theta 2 and theta 1 plus theta 3. So this is, I think you can do it yourself. This is another homework. Then last class I already defined S is due to blue for linear functions and then also define independent linear functions. So please try this problem yourself. Okay. Then the SS due to blue of theta 1 plus theta 2 the SS due to error. Okay, so please tell me, have you any problem? Okay. Can you solve this problem yourself? I think you solve this problem yourself. This is your homework. Okay, so next problem, problem 3. This is 2. Let y1, y2, y3, y4 be 4 uncorrelated observations with expectation y1, expectation y2, expectation y3 equal to expectation y4, beta 1 minus beta 2, and variance of yi sigma square for all I from 1 to 4. Show that beta 1 plus beta 2 plus beta 3 is estimable W of beta 1, find the blue of beta 1 plus beta 2 plus beta 3, and then variance of blue of beta 1 plus beta 2 plus beta 3. Okay. Find two orthogonal linear functions belonging to error space, hence find unbiased estimator of sigma square and test find the orthogonal projection of on the column space of A means if you write these observations as this, then you can find find 2G inverse of A prime A such that A prime A G inverse A prime remain constant. So this is another homework. S is due to linear function script L, the set of linear function is a linear set generated by k linear function t1 t2 tk, where ti equal to ci curl prime y curl then we know S is due to script L is a norm of y naught curl square, where norm of y naught is a length of the projection on column space of C1, C2, Ck, and we can write this as T curl. We have already seen this thing in our previous class. This is matrix C prime y curl, where C is a matrix constructed by vectors C1, C2, Ck. Where T curl hat is any solution of this equation this. Let C prime C G inverse is a G inverse of C prime C, then T curl prime hat, this is equal to then S is due to scriptal equal to T curl hat prime C prime y curl, this is equal to T curl hat means this, so y curl prime C prime C G inverse C prime y curl. This is a quadratic form of in Y. The matrix of the quadratic form I denote this by W matrix. Check that this W is symmetric and idempotent. With rank equal to R, which is a dimension of column space of C. Suppose T1, T2, Tk are all linearly independent functions, then S is due to scriptal, this is equal to y curl prime C prime inverse instead of G inverse, because all functions are linearly independent. So C prime C is a full rank matrix, so it is invertible. Again, dispersion of T1, T2, Tk, which is dispersion so these are vector. Okay, so dispersion matrix. This is a C matrix. Okay. This is C1 prime y curve. That means C should be 1 cross n, so C should be okay. Then okay, alright. So we write this as a C prime y curve. So dispersion of C curl prime y curl, this is equal to C prime dispersion of y curl C prime C sigma square, because dispersion of y curl, this is equal to sigma square I. Alright, so C prime C inverse, this is equal to dispersion of T curl by sigma square inverse, where T curl, this is nothing but a T1, T2, Tk prime. Okay, so therefore SS due to alpha, we write this as y curl prime C equal into dispersion of T curl sigma square inverse. So we replace this C prime C inverse by this dispersion of T curl by sigma square whole inverse into C prime y curl. Again, this C prime y curl, this is nothing but a T curl. So T curl prime dispersion of T curl sigma square whole inverse T curl. So this is the another formula of SS due to alpha. Okay, so instead of computing this T curl prime hat C prime y curl, because this is tedious, sometimes this is very tedious, so rather you can use this formula T curl prime sigma dispersion of T curl by sigma square whole inverse T curl, which you can easily compute. So for computational purpose, you use this formula instead of this. Okay, so please tell me, have you any problem? So I see Shubhodip is here, so please tell me other 4 persons who are there except Shubhodip. Please say in comment section hello, hi, etc. please tell me, have you any problem? Except Shubhadeep, please tell me other 4 persons who are watching this video. Have you any problem? So now it is 4. Okay. Shashwati, no doubt sir. Okay, thank you. Then other 3. Shubhadeep and Shashwati. Except Shubhadeep and Shashwati, other, what about other 2? Now it is 6. Okay. Let C1 curl prime y curl. No, I know Shubhadeep, you are present. Shubhadeep Mojumdar, okay. Shubhadeep Chakraborty, Shubhadeep Mojumdar. Thank you, Shubhadeep. So I see Shubhadeep Chakraborty, Shashwati De, Shubhadeep Mojumdar are present, but I want to know other 3 persons who are watching this video. Let C1 curl prime y curl, C2 curl prime y curl, CK curl prime y curl be K orthogonal linear function giving scriptal, the script, then SS due to scriptal is equal to SS due to C1 curl prime y curl, C2 curl prime y curl, CK curl prime y curl, so this is equal to SS due to C prime y curl, where C equal to C1 curl prime, C2 curl prime, CK curl prime. Okay. And we already see that this is equal to C prime y curl prime C prime C inverse C prime y curl, and since C1, C2, CK are orthogonal linear function, this means this is C1 curl prime C1 curl, this is a diagonal matrix and diagonal elements are C1 curl prime C1, C2 curl prime C2 and kth diagonal element is CK curl prime CK. Capital C prime y curl. So this equal to sum over y from 1 to n Ci curl prime y curl by Ci curl prime Ci curl. So this is nothing but a S is due to Ci curl prime y curl, and we can easily generalize this result that is, let script L I is a subset of script L. Script Li is orthogonal to script Lj, and R equal to R1 plus R2 plus Rk, where Ri equal to degrees of freedom due to sum of square due to L I from 1 to k, and this R should be degrees of freedom of Ss due to degrees of freedom due to Ss due to Li, not L, script L, and R is the degrees of freedom, Ss due to script L. Then Ss due to script L is equal to Ss due to script L1, Ss due to script L2, Ss due to script L k, with degrees of freedom R, which is again obtained by sum of Ri's, where Ri is a degrees of freedom of SSL. So this is the partition of, this is called the partition of partitioning Ss due to linear set so this is partitioning of Ss due to linear set. So this is nothing but a Cochran's theorem. Actually in ANOVA we see that we partition the different source of variations. Actually in ANOVA our job is to split total variation into some source of variations. For example, if you consider one-way ANOVA, there are only two sources of variation. One is error, another is factor, or you can say it is group or treatment. And if you consider two-way ANOVA, then you can split into three parts. One is block variation due to block, another is treatment, another, and third one is error. Okay, so all and this is happened because all these three are ortho complement space to each other. Okay, so this is the statement of Cochran's theorem. So this thing is obtained just generalizing this result. So if you have any problem regarding this statement, please tell me. Can I wrap this portion, Shubhajit? Shashwati? I run this portion? Okay. So sum of square due to estimates by sum of square due to estimate is defined as defined to assess due to the blues of all estimable parametric function so this is same as SS due to blues of are independent estimable parametric function where R is rank of A, where A is a coefficient matrix. So this is same as S is due to A prime y curve and S is due to all blues. This is equal to S is due to A prime y curve. So this is equal to T curve prime hat A prime y curve, where T curve hat is a solution of A prime A T curve A prime y curve. So S is due to estimate this is equal to theta curve prime A prime y curve and where theta curl hat is a solution of a normal equation Therefore, and one thing I want to mention, this is just obtained if you look at the normal equation a prime a theta curve equal to a prime y curve, then t curve can be taken as theta curve hat, which is a solution of a normal equation. So for this fact we can write SSDT estimate is theta curve hat prime a prime y curve. Okay, where theta curve prime hat is equal to a prime a g inverse a prime y. Again I repeat this thing, if you compare this, so you see that this is same as a normal equation of linear model. If you replace theta curve by t curve by theta curve, so SSDT estimate is nothing but a theta curve prime hat a prime y. Okay, just I replacing theta curve t curve prime by theta curve prime hat. So this is equal to y curve prime a prime a g inverse a prime y curve. Note that theta curve prime hat, this is equal to a prime a inverse g inverse a prime y curve. So SS due to estimate this is nothing but a, just you replace theta curve prime hat by this, you get this. Again, a prime g inverse a prime, we already know this thing is a projection operator of y curve on column space of A. So SS due to E is SS due to error that is SS due to error means SS due to error functions and suppose Ci curl prime A equal to 0 from I from R plus 1 to N. So that means Cr plus 1, Cr plus 2, Cn all belongings to, or rather we can say this can generate the error space because these vector are orthogonal to columns of A. So SS due to errors, so equal to SS due to error functions, that is equal to SS due to C1 curl prime y curl, C2 curl prime y curl, not C1, Cr plus 1 I think so. Sorry, this is Cr plus 1 curl prime y curl, so Cn curl prime y curl. Okay, so this is nothing but a T curl prime hat C prime y curl, where T curl hat is a solution of the equation C prime C T curl C prime y curl as above, but here C is a matrix which comprises with the columns of which constructed by the vector Cr plus 1, Cr plus 2, Cr plus n instead of C1, C2, Cr. If you use C1, C2, Cr, then you get the SS due to the estimates, and if you use Cr plus 1 to Cn, then you get SS due to error. Okay, please see carefully. So any observations y curl belonging to Rn you can write this into two parts, alpha curl plus gamma curl, where we know alpha curl is a projection of y curl on column space of A, and gamma curl is a projection of y curl on ortho complement space of column space of A. Okay, so alpha curl is a projection of the column space of A, and gamma curl is a projection of y curl on ortho complement space of column space of A. So SS due to all observations y1, y2, yn. So this is nothing but a y curl prime y curl. Now SS due to script L, I denote this by SSL, is a SS due to L alpha 1, SS due to L1, SS due to L2. We already know this thing, provided this L1, L2 is a subset or subset of script tail, and these two linear set are orthogonal to each other. We know this result. We already see this thing. We have already seen this thing. So, where script tail, the space generated by y1, y2, yn, and script L1, the space of all blues and script L2 error space, and script L1, script L2 is a subset of script L, and script L1 is a orthogonal to script L2. So we also see that here R, which is a rank of L1, and that is the degrees of freedom of L1, and n minus R, which is the degrees of freedom of L2. This gives n. So SS due to all observation, that means this is nothing but a SS due to estimate plus SS due to error, and sum over yi square 1 to n, which gives SS due to all observations, and we know SS due to estimate already. We get this thing a prime a g inverse a prime y curl plus SS due to error. So SS due to error is nothing but y curl prime I minus a prime a g inverse a prime y curl, because this thing is obtained by sum over 1 to n yi square minus y curl prime a prime a g inverse a prime y curl, and this summation yi squared can be written as a y curl prime y curl. So we get this with degrees of freedom. We already see this thing, degrees of freedom n minus r. So here we see that first a prime a g inverse a prime and I minus a prime a g inverse a prime, both are matrices of quadratic form, QF in short. I denote this QF in short, Q for quadratic, F for form. So we moreover you check that both are symmetric idempotent matrix matrices, and rank of a prime a g inverse a prime equal to R, and rank of I minus a prime, a G inverse a prime equal to n minus r. Please check this thing. These are your homework. Okay. So please tell me, have you any doubt? Can I rub this portion? Shashwati, Shubhadeep. So next part is testing of linearity of parametric function. Okay, thank you, Shobhit. Suppose h curl prime theta curl be an estimable parametric function. We want to test h naught, which is equal to h curl prime theta curl equal to xi curl, xi, not xi curl, is a scalar part. It's a scalar quantity, so this should be xi. Where xi is a given constant, we know that as h curl prime theta curl is an estimable parametric function, h curl prime, the h curl belonging to column space of a prime a, since it is estimable, we know this thing, that is, there exists a vector q curl such that h curl equal to a prime a q curl, because h curl belonging to column space of a prime a. In this case, q curl prime a prime y curl is the blue of h curl prime theta curl, where q curl is given by a prime a q curl equal to h curl. we know all these things. So now for testing, we assume that y curve, for estimation we do not need the distribution, assumption of the distribution of y curve, but testing we need to assume the distribution of y curve. So here we generally assume that in linear model y curve belonging to normal n-dimensional normal distribution with mean vector a theta curve and dispersion matrix is sigma square I. That means yi is uncorrelated. So this implies if we apply the result of multivariate, this is the undergraduate, in undergraduate course you know this result. So this is and dispersion is I denote this mean vector by h curve prime theta curve because h curve L is a prime a q curve. Already I mentioned this thing, and this is as dispersion portion. Okay, so you see that the order of this is, because this is a scalar, because q curl prime a prime y curl, so it is a univariate normal. Univariate normal with mean is h curl prime theta curl and variance is q curl prime a q curl. Okay. So therefore z defined as, this is a q curl prime a prime y curl h curl prime theta curl by sigma root over q curl prime a q curl. So this follows normal 0 1 and under h naught this z because under h naught h prime theta curl equal to xi, but this z cannot be used as a statistics because this sigma is unknown. Again I repeat this thing, we cannot use z statistics because sigma is unknown. So we need to estimate sigma, and the estimate of sigma hat square is nothing but a the degrees of freedom, this error, sum of square root error is n minus r. So we denote this by MSE mean sum of square due to error. And why I take this an estimate of sigma square, because we know y curl prime a prime, this is again the result of multivariate a prime y curl, since y curl freedom follow multivariate normal. So this again, since this is the idempotent matrix, so this quadratic form follow chi square with degrees of freedom, rank of this matrix, rank of this idempotent matrix, okay, and rank of this idempotent matrix is n minus r and into sigma square. Therefore expectation of this part SSE, this part is equal to sigma square n minus r, and expectation of MSC, this is equal to sigma square. Again I repeat this portion, since y curl follow multivariate normal with n-dimensional multivariate normal, and so this quadratic form y curl prime I minus a prime g inverse, not inverse, g inverse a prime y curl, this quadratic form follow chi-square distribution, because this matrix of quadratic form, that is I minus a prime a g inverse a prime, is a idempotent matrix. So this follows chi-square with degrees of freedom equal to rank of I minus a prime g inverse a prime, and rank of a prime a g inverse a prime is nothing but n minus r. Hence this follows chi-square with n minus r into sigma square. Therefore expectation of SSE, because SSE is nothing but a y curl prime I minus a prime a g inverse a prime, so expectation of SSE is nothing but a sigma square of n minus r. Therefore expectation of MSC, which is MSC is SSE by n minus r, so expectation of MSC equal to sigma square. Therefore sigma hat square MSC is a unbiased estimator of sigma square. So instead of sigma, because sigma is unknown, we use sigma hat, and in that case q curl prime a y curl xi by sigma hat q curl prime a q curl, this follow t distribution with n minus r degrees of freedom, because this portion you can these portions come from the estimation space q curl prime a y curl, this is from estimation space, and this come from error space. So these two are independent, and q curl prime a y curl follow normal distributions, and sigma SSC follows chi-square with n minus r sigma square. Therefore this ratio follow t distribution with n minus r degrees of freedom, and I denote this statistic by t, and we reject h naught at level alpha if mod t greater than t alpha by 2 n minus r, otherwise accept it. Not if, only if. Otherwise accept it. Here we also see that this t square is nothing but f, where this f follow f distribution with 1 n minus r degrees of freedom, and again we reject H naught at level alpha if f greater than f alpha 1 n minus r, otherwise accept. So either you proceed using T distribution or by using T distribution or using F distribution, and the rejection regions are as follows. Okay. This is case 1. Next, case 2. Let there be k independent estimable parametric function h1 curl prime theta curl, h2 curl prime theta curl, hk curl prime theta curl. We want to test h naught hi curl prime theta curl equal to xi I from 1 to k. And this can be written as a and where h equal to h1 curl, h2 curl, hk curl and xi curl prime or xi curl equal to xi1, xi2, xik prime. Here, moreover, xi this is a given vector of given constant. This is a vector of given constant. As hi curl prime theta curl is estimable for all I, then we know this thing hi curl equal to a prime a qi curl for some vector qi curl I from 1 to k. So this implies h which is equal to h1 curl, h2 curl, hk curl. This is equal to a prime a q1 curl, q2 curl, qk curl. This is equal to a prime a q. Q is a matrix forming by q1, q2, qk vectors. The blue of hi curl prime theta curl is given by qi curl prime a prime y curl I from 1 to k this imply the parametric function in PF means parametric function, parametric functions in h prime theta curl are estimated by q prime a y curl. Because h prime theta curl hat is equal to q prime a prime y curl. I know this thing. Now q curl prime a prime y curl contains k independent linear function, so this follows k dimensional multivariate normal distribution with expectation of q curl prime a prime y curl is nothing but h prime theta curl, and dispersion matrix is q prime a prime a q, just using the result of multivariate. And so z curl is defined as q prime a prime y curl minus h prime theta curl prime q prime a prime a q whole inverse q prime a prime y curl h prime theta curl. So this into 1 by sigma square, then this is a quadratic form, and I think it is better to write in that way. So this is a quadratic form, and this follow chi square with k degrees of freedom. Okay. Under h naught. And otherwise I denote this by okay. Otherwise this portion 1 by sigma square q prime a prime y curl h prime theta curl prime q prime a q inverse q prime a prime y curl h prime theta curl. This follows non-central chi-square with k degrees of freedom and non-centric parameter is is a non-centric parameter lambda is equal to q prime a prime y curl xi whole prime q prime a non-centric parameter lambda, this lambda equal to q prime a prime y curl xi curl whole prime. Just use the result of and hence, since sigma square is unknown, hence this portion divided by k into MSC. So this portion divided by k into MSC, this follows F distribution with degrees of freedom k and degrees of freedom of MSC is n minus k under H. Okay. So we use this as a statistics for testing this. So please tell me, have you any problem or doubt? Next theorem. Consider the linear model then SSC is nothing but a minimization of this with respect to theta curve is distributed as sigma square chi square n minus r degrees of freedom, where r equal to rank of A. Okay. Given that rank of A equal to R, which is less than equal to P, and we choose alpha 1 alpha R. So since rank of A equal to R, this means we can choose alpha curl comma alpha R curl as a orthonormal basis of column space of A. We supplement the we extend the basis of, sorry, not the basis of, extend the basis of column space of A to an basis of Rn by adjoining n minus r vectors. I denote this vector by alpha r plus 1 to alpha n, such that alpha 1 alpha r plus 1 alpha n be an orthonormal basis of Rn. Therefore, this matrix, if you form this matrix using the vector alpha 1 to alpha n, and we denote this part by F and denote this part by G, is an orthogonal matrix. Okay. Note that F prime G equal to 0, F prime F equal to IR, G prime G equal to In minus R, G prime A equal to 0. Just since this is orthogonal matrix, you can see that A prime G prime Fg equal to In, and partition In as I0, IR0, 0, In minus R, and comparing both sides, you get this. Okay. So now transform y curl to z curl, where z1 curl equal to f prime y curl and z2 curl equal to z prime y curl. This means z1I is equal to alpha I curl prime y curl, I from 1 to R, and z2I equal to alpha I curl prime y curl, where I from R plus 1 to N. Okay. So therefore, this implies z curl, z1 curl, z2 curl. This is a prime y curl, g prime y curl is equal to a prime g prime y curl equal to w y curl, where y curl equal to w inverse z curl, since w is orthogonal matrix, so it is invertible. So y curl equal to w inverse z curl, and hence expectation of z1, this is nothing but a prime a theta curl, and expectation of z2, this is equal to g prime a theta curl, but g prime a 0, so this should be null vector. And moreover, y curl a theta curl whole prime, y curl a theta curl, so this is equal to y curl a theta curl prime, and I y curl a theta curl, and y curl a theta curl prime, I means this. So I write this as a prime f prime z prime f z prime z equal to y curl minus a theta curl. Okay, so I think it is better to write just this form instead of this, just f prime g prime f g. Okay, so now we see that f y curl a theta curl I think it is better to write if G, because it is orthogonal, because it is an orthogonal matrix, so this thing also satisfied. Okay, so f prime this no. F prime G prime. This means okay. So this is equal to this is not a prime. F prime G prime. So then then this is equal to f this is equal to f y minus a theta curve whole prime g y minus a theta curve whole prime f y curve a theta curve g y curve minus a theta curve. Okay, so therefore this is equal to fy, I denote fy by z1 and f prime a theta curve prime, and since ga is 0, so ga theta curve is 0, so this is nothing but a gy curve whole prime. Similarly, this is z1 curve a prime a theta curve zy curve, and z1 curve is equal to fy curve, and if you denote this is z2 by gy curve, so I replace this z2 curve and this should be z2 curve prime. So this is equal to z1 curve minus a prime a theta curve whole prime z1 curve a prime a theta curve plus z2 prime z2 and this portion is independent of theta curve. So now minimization of this a theta curve prime a y curve a theta curve is same as minimization of a prime a theta curve prime z1 a prime a theta curve, because this portion is independent of theta curve. So this is and from normal equation this get, so we can choose theta curve, just differentiating this thing, and if you then we choose theta curve such that a prime a theta curve equal to z1 curve. Okay, because see why this thing happened, because this is a simply as a u curve prime u curve, so this is nothing but a summation ui square. So summation ui square always greater than equal to 0, minimum is ui summation ui square equal to 0, and summation ui square equal to 0 you can only when the individual terms also 0. So minimization of this is nothing but a 0, and we choose theta curve from this. Okay, understand? So So number of equation in this equal to R equal to, and rank of coefficient matrix f prime theta A is equal to rank of f prime A. This is equal to rank of f prime A 0 curl, and 0 curl means not 0 curl, 0. And f prime A g prime A and this is equal to rank of f prime A g is nothing but a rank of A, because f prime g prime is a orthogonal matrix, and we know if you pre-multiply or post-multiply by non-singular matrix, rank is unchanged. Okay, so rank of coefficient matrix f prime A is nothing but a rank of A. This means, and rank of A is R, so this equation is solvable. This equation is solvable. So this means there exists a solution of theta curve such that f prime A theta curve is equal to Z1. So therefore minimum of this is simply as Z2 curl prime Z2 curl, because this portion is 0. So Z2 curl prime Z2 curl, and we know Z2 curl follow normal. You can easily find this thing. This is Z2 curl follow n minus R 0 curl, because the expectation of Z2 is nothing but a GAY curl. Since GA is 0, so it is a 0 curl, and dispersion is G prime G sigma square, and G prime G is I n minus R sigma square. Hence this follows sigma square chi square with n minus R degrees of freedom. Okay, so I want to stop today. Next class, this is, I think it will be the last class. In the next class I will discuss problem number 2 and 3 in detail, the solution of problem number 2 and 3 in detail, and the last portion of this linear hypothesis topic. So I think the next class will be the coming Thursday is the last class of linear model. So please, this class will be at 10 a.m. morning. So please join. So thank you. If you have any question, please tell me. Otherwise, I want to end this string. see this portion is 0, so that means minimum of theta, this is nothing but a Z2 curve prime Z2 curve, and Z2 follows normal ni multivariate normal n minus r dimensional normal distribution with mean vector 0 and dispersion matrix in minus r sigma square. So that means Z2 prime Z2 follow chi square with n minus r degrees of freedom. Okay. Okay. Thank you. So so now I end this string. Thank you everybody.